My name is Carolyn Crow. I'm a second-year graduate student at UCLA in the Earth and Space Sciences department, and I am studying geochemistry. I'm looking at lunar rocks, so I have Apollo 15 and 14 and 17 samples, and I look at the zircons, which is a certain kind of mineral in the rock. So these are little clasts, which just means it's a smaller piece of rock, from Apollo 15. And we got a bunch of different samples in here. And one of the neat things about moon rocks is, you can probably see it, is that they're really black and white in color. So there's really two different parts. There's the white, which is anorthosite, which is the lighter material, which is the first material to crystallize on the moon. And then you have the darker part, which is basaltic material, which is where most of the zircons come from. The zircons are really great for uranium lead dating and lead dating because the crystal structure of the zircon really likes to take in uranium and thorium and other rare elements like that, but it doesn't like to take any lead into its crystal structure. So when you're doing uranium lead dating, you have uranium that decays into lead, and you look at the amount of the parent uranium and the daughter lead in the crystal in order to figure out how old it is, because we know how fast the uranium turns into lead. So zircons are great because we can just assume that there was no daughter product at the beginning. So it allows us to make fewer corrections, and also allows us to have a much more accurate measurement of how old it is, just because of the way that the crystal structure takes in different elements. A lot of astronomers are trying to make models of how the solar system formed, and there's a lot of different events that's happened during that time. And as a geochemist, I'm looking at the rocks to try and figure out when these events happened and the timing, so that the astronomers can model or make their models to match up with the data that I have. So it's the only concrete evidence that we have for the formation of the solar system, other than looking at other solar systems that we see forming.